time-lapse animation there. Always fun, but not much else really to look at today. It's just been kind of clear and dry out here today. Nice sunshine there, and there's a bird up there. Maybe one of you can identify it. I have no idea what that bird call is, but if one of you know, let me know in chat, and I'll go ahead and share that. Let's see, what do we got for today? Not a whole lot. Got that southeasterly flow back in place, so the Bermuda High is active across Texas. We're back in the deep tropical flow. But up to the north, a little bit of action up there near the Kansas-Oklahoma border. You see this little cluster of storms from about Springfield, Missouri up to Chanute, Kansas, a little bit more from about Wichita to Medicine Lodge, Kansas. So what's causing that? Well, we can change the sector here, and we'll take a look at the data. And we see a much different air mass. Let me switch off the radar so you can get a better look at the plots. So are you all seeing this here? The easiest way to make sense of this map is to look at the very bottom down here and then look at the very top. So basically look at the extreme ends of the map. That's the easiest way to do that. And actually place yourself there. So say we're hanging out in Nashville, getting a sandwich or whatever. We have 87 degrees and there's fair skies down there. Dew point is running about 63, so it's a little bit on the moist side, but it is pretty hot. And then at the other end of the scale, we're up maybe at Madison or La Crosse. We've got northeast winds there and clear skies and a very cool 73. So generally your process of analyzing is starting in the warm part of the map, say right here near Nashville, and go north and see if the air mass is pretty much the same. Yeah, when you get up to the Ohio River it is. But once you get up into Indiana and Illinois, there's a definite change here. We cool down into the mid-70s. We've got some clouds here and light west winds. And then, if anything, the temperatures get cooler as we go north. So the very first place where we notice a transition to a different air mass is where we place the front. And that process just continues with different parts of the map. So we go from around, trying to remember the cities here, Jackson, Tennessee, up to maybe like Des Moines. We find our change here pretty quickly from low to mid 80s, right around down here, and then we hit those cooler temperatures here. So we put another mark there maybe. So by doing that, we can kind of get an idea of the general location of that boundary. And so today that's going to be something like this right here. So we're finding the fronts a little bit along and just north of that boundary. So taking that all the way down into Kansas, we catch a little bit of that tail end all the way through here, through the Ozarks, and along the Oklahoma-Kansas border. And that is what is helping trigger these storms. We're getting some convergence along that boundary and a little bit of low-level lift, and that's just enough to overcome the cap and get a few storms forming. So this is the big picture here, and you can certainly see how the storms are all oriented in this line here. So that's suggesting where the front is. So north of that we have cool northwesterly or westerly winds, and then south of that we've got that moist tropical flow from the Gulf. This is the SPC convective outlook, and they've got a marginal risk in place, mostly there in Kansas. And we can take a closer look at that with the WSR-88D radar. I pulled up Wichita here, And we're looking at Sedgwick County right here. This is Wichita. And we've got ourselves a little storm there pretty close to the radar. This is going to be about 20 miles, so we're zoomed in pretty close. So what kind of severe weather features are we seeing? Usually the first thing that I look for is the strong reflectivity gradients on the inflow side of the storm. And yeah, those are kind of piled up towards the southeast side of the storm. So the higher gradients or the higher values are down here, and then the main bulk of the storm is something like that. So they are kind of shifted, the higher values are shifted to the south part of the storm. Any hook echoes, anything like that? Well, there might be a little hook there. That could just be a little artifact. But the one thing I'm not really seeing here is the flying eagle appearance that we sometimes see with a supercell, where you get something like that. So things are looking a little bit disorganized. This kind of has the look of maybe a multi-cell thunderstorm. And the other thing that I want to consider here is the outflow boundaries, and we do see one here. See that area of higher reflectivity? That kind of hints at where the outflow boundary is. So it looks like it's just ahead of the storm, maybe approaching the rain-free base, which is going to be in this area. And I can also use the spectrum width to help find the location of that. And we don't see that quite as well. However, we can see a change from low diversity patterns here, where you see this subdued gray, to high diversity patterns way out here. So that kind of suggests that maybe there's an air mass transition right there. So you can take that and kind of resolve that with your reflectivity image and get an idea where the outflow boundary is. If that's drawn up very close to the storm, like this tells you that the storm is very inflow dominant or balanced. And when we see it way out ahead of it by a few miles to 10 miles or more, we consider that to be outflow dominant. And at that point, the main risk of the storm is going to be stuff like hail and just strong winds and lightning, and that's pretty much about it. So we just pulled in this new frame, and we're seeing the outflow boundary, probably something like that, just slightly ahead of the storm. It looks a little bit outflowish to me. Let's check out sounding real quick, and this is Norman. This is about as good as we can get for an inflow sounding, because or a proximity sounding. Because if we look at the big picture, I'll bring up the radar here real quick. The storm is located right here. The problem is we have one sounding site here, another here in Springfield, and another at Topeka. They're very widely spaced. So our choices here are very limited to which sounding we're going to pick. So it looks like it's going to be Oklahoma City. And that probably pretty well samples the air that's heading up this way towards Wichita, because at 12Z this morning, the moisture feeding that storm is probably in central Oklahoma, and then during the day it works northward. So what does that sounding look like? Looks a little bit dry. I'm looking at the moisture being this green line coming up from the surface. It starts out right here at about 21 to 22 Celsius. So that's about 70-degree dew point. And then the important thing is it tapers off and falls with height, which means that when we have heating during the day, dry air is going to start mixing down to the surface. And here's a pocket of pretty dry air right here. This would be 50s dew points up at about 5,000 to 6,000 feet. So that's definitely going to work down to the surface, and you're eventually going to average this 50s dew point air with this upper 60s dew point air, and that's going to take the overall dew points down a little bit. So when we construct our lifted parcel, it's going to look something like this. Maybe that's a pretty good estimate. So that LCL is up at about 8,000 feet. So these storms are very likely high-based. And if we lift our parcel and we compare that to the environmental trace that we have here plotted already, we can see that we're only very slightly to the right of this temperature line. And we're pretty well capped here. So it looks like the instability is really marginal, maybe looking at values of maybe 1,000 of 1,500 at the most, I would say. So stability is a limiting factor, moisture, and that's just a quick look at the soundings right there. Let's see here. Okay, I was checking on the chat real quick. We're going to cover some of those topics in just a minute. That's coming up on the chat feed. Anyway, I decided to pull up the continental U.S. sector here so we can get a closer look at the moisture affecting our area over the next week. So we start out with this front. You can definitely see that on this precipitable water panel. The higher values here just kind of like bear that out. So north of that, we have that northwest flow, and south of that, southwest flow. So what's going to happen over the next few days? Looks like that boundary is going to pretty much stall in the same location across the Midwest. Texas is going to stay in southerly flow. And it looks like a couple of shots of marginal moisture heading up into East Texas here. So it looks like the moisture will be coming up in Texas a little bit as the week progresses. Then it looks like the front finally pushes down over the weekend. Look at that, all this dry air heading southward. And it does look like it stalls across Texas around Sunday or Monday, so we're probably going to see precipitation chances continue to be a little bit on the like 30 to 50% range, maybe something like that, 20 to 50. So we've got more moisture coming up from the south. You can see this return flow start up, but then we have another shot of cold air coming down. And you can see the low pressure system associated with that up in Canada, right here over the Great Lakes, actually. Now, I am getting a question here about baroclinic storms or baroclinic systems, which is what this is. This is not a fully developed baroclinic system, so I really don't think I can go into much detail on this without really drawing this segment out. But the important thing about baroclinic systems is they bring together contrasting air masses. So in this case, cool northwesterly flow from Canada, and warm air from the Gulf, and it brings those together. And that has an effect on the upper level patterns. It tends to strengthen the jet stream. We see, if we looked at the isotax up at 500 millibars at this time, maybe I can switch over to that real quick. Let me do that real quickly. 250 heights and winds, we'll bring that up. And let's see, when was that? Okay, we were looking at September 13th for that frame. So let's see what's going on September 13th. Okay, so there's September 13th. You can see how the upper level flow strengthening across the Great Lakes right there. Got much stronger winds. So that's the upper level response to the convergence at the surface, bringing those different air masses together that helps sharpen the height gradient aloft and increases the wind speed due to the geostrophic winds increasing. And as a result, the vertical motions we get ahead of waves moving through this feature will tend to favor even stronger vertical motion, and that feeds back into the surface system. And we call that the chain of development, the cycle of development right there, baroclinic development. See, I lost my place here. Okay, let's continue on with our forecast. We're mostly affected by fronts way down here over the next week. Just getting the tail end of these Great Lakes systems, these backdoor fronts coming into Texas. And then it looks like the precipitable waters really increase next week. We're getting out to September 16th, 17th, 18th. Then we get another shot of dry air coming on down. So things are starting to slowly get a little more active starting next week, it looks like. Okay, I was going to go through the Atlantic systems, but I think that's going to kind of draw things out. The important thing is that the charts are looking a lot like what we had yesterday. It had one initial system right here that kind of recurves to the north. And then this other system here just kind of stays nondescript and heads toward Dominica. It doesn't really make it here by the end of the frame. And I was looking at some of the ECMWF products. This is the European model. It's a model that's a lot like the GFS, with the main difference being that we don't have as many products to look at. So you see here we only have 850 millibar winds, sea level pressure, and 500 millibar heights. So as I've mentioned before, they're extremely picky about what data they release to the public, so we can't really avail ourselves very much of this model, unfortunately. I do think one of the sites out there has some data. I want to say maybe it's Earl's page or one of those others. I'm going to dig around and see if I can find that, because I think there may be one exception out there. I'll have to check that out. There's not much in the way of systems to look at. If I run this out to next week, you can kind of see high pressure over the Great Lakes pushing this front to the south, but not really a whole lot to look at, just a few isobars here. That's about all we have to go off of here. There's no winds and no precipitable water, nothing like that. So these charts are of very limited use, unfortunately. Okay, and I think that's about all I have for today. So I think we're going to start getting a little bit more active here with this front coming down over the weekend, and if we do get some strong storms and EMCSs, I probably will run a special program here, and we'll follow the storms and learn a little bit about radar and how to work with that. Let's see. Yep. I think that's about all I got here, so I will see you tomorrow at the usual time, 8 o'clock. I appreciate you watching, and we'll see you then. Bye-bye.